Hello, college algebra student. This video is for 2.6 other types of equations. So in chapter 2, we are learning a lot or reviewing a lot of old algebra techniques, and the most important technique is to solve equations. So we solve linear equation, we solve quadratic equation. Now we are solving all others. So linear and quadratic are the most important one, but there are a lot of others that is also important to model real life applications. So how do we solve those equations and what are those? So I'm going to briefly cover what we are going to cover. First is equation that has an exponent, rational exponent, like this. X to the not square, not cube, but fraction exponent. Okay, so we'll talk about how to do it in this video. C would be solve a polynomial equation, meaning is x to the something that is higher than 2. So x5, x7, well, no, x5, x to the 4th here. So we'll look at those that has 2 terms as well as 4 terms in particular. So polynomial equation, and then the next one is radical equation. That means that unknown is in a radical. So how can we solve those? So that would be in the, I think, next videos. So and then 2.6 also had solve equation that is absolute value. That means your unknown is trapped inside an absolute value. And then lastly, we also solve equation that is in quadratic form. That means there's two groups, or there's groups of things that look like they are square of each other. So we call it quadratic form equation. So we'll solve those. So we see how we solve a lot of different types of equation. And that is 2.6. Okay, so 2.5 we do quadratic, which is very important. And 2.6 we're solving all others. So these equations are important for calculus. In calculus, you would need to solve these kinds of equation. So before we solve, so the first one is solve those with quadratic, no, not quadratic, with an exponent that is a rational number. That means like a fraction exponent. Okay, so how do we solve those? We would use something called the reciprocal of that exponent to solve. So first of all, let's look at what is the meaning of a rational exponent. So in a nutshell, the most basic one is if I'm doing a root of something, that is a 1 over of that root. So everybody knows that if I'm doing a square root of a, that is a to the 1/2, because square root means there's the index is 2, outside is 2. If I'm doing a cube root, that is a to the power 1/3. It is just how you define it. A root is 1 over of that. So likewise, if I'm doing a fifth root, there will be a to the 1/5, right? So this is kind of the root and the 1 over notation. What about if I have not 1 in the numerator, but m over n? So it turns out that m would just be a regular exponent. So you can do it by thinking 1 over n, still do a root, and then the m is waiting outside. Or you can say, well, it is a to the m, but the root of n. So whenever you see an exponent that has a denominator of n, you think of root. Okay, denominator in the exponent is root. Anything that is in the top is just an exponent. It could be inside or outside. What about if I have a negative exponent? Negative exponent is a reciprocal. So if I have a to the negative of n over m, that means just 1 over that. Okay, so say for example I have a negative 1/2. That means 1 over square root a. Okay, the a 1/2 is square root, right? Negative means 1 over it. So with those definition in mind, we're going to simplify some numbers. So this is very important in calculus and also solving this equation. So a to the power 2/3. So this is not multiplying. Okay, it's to the power. So it's like a power index. So the first thing we want to look at is there is a 3 in the denominator of the exponent. So it must be a cube root. So we automatically write cube root. And what about the square? Oh, it can wait outside. For numbers, we usually take as small a number as possible for root and then square it later. No one want to do the square of a bigger number and then take the root. It's just harder. So what is the cube root of 3? Cube root of 8. So what number when they multiply 3 times is equal to 8 is 2. So that means 2 square, so that's 4. The next one is 25 to the negative 1/2. This is a negative, so I write it as square root of 25. Do I have to square anything? No, the top is 1, so just take square root. So it's 1/5. Okay. So solve. The second part is solve rational exponent. Equation with rational exponent. That means you have an unknown a, x, but then it has not a square, not a linear, but something exponent equal to a number. So the idea is you raise both sides by a power that's the reciprocal of this exponent, and then simplify. So this side. So you say, what happened is, if I have a 5/4, x to the 5/4, I write this way, I want to do another exponent so that this would cancel. Because I want x equal, right? I want x equal. X equal means x to the power 1, right? X is x to the power 1 equal to what? Like that. So I wanted this to be 1, so I would multiply the reciprocal of 5/4. What's the reciprocal of 5/4? It's 4/5. So I write 5/4, and then at the same time, I do 4/5 outside. And because I do 4/5 on this side, I do 4/5 here also, right? So they are the same. And this would cancel as 1. 1 we don't write. We can write 1, but we don't have to write. And then this would just be simplified. So 32 to the 4/5. Okay, so not this one, but the reciprocal of it, 4/5. What is 4/5? That means I'm doing the 5th root, because in the denominator of an exponent means root, and then 4 times. 5th root of 32 is 2 to the 4, 2. This is 2, because 2 times 2 times 2 times 2 times 2, it is equal to 32. So if I do the 5th root, that is 2. And that's 16. Next is solve x 3/2 equal to 125. So 3/2 is a rational exponent. I'm going to raise it to the reciprocal of it. So 3/2. What is the reciprocal of 3/2? It's 2/3. Because you can tell 3/2 times 2/3 is equal to 1. So in this side, I need to do the same thing. 2/3, right? So this would cancel as x equal. That's what we want. But this would be doing a root of the denominator cube. Oh, earlier this looked like a cube. This is actually a 5, right? Still look bad. So this is cube, and then a square left over. So cube root of 125 is finding a number that is multiplied 3 times equal to 125. Of course, that is 5, right? Because 5 times 5 times 5 is 125. And then square it. So that is 25. Okay, so solving an equation that has this, you just multiply the reciprocal of that exponent. The second one, the second types of equation is polynomial. And this is the one where I have 2 terms. Okay. And you can see that if you have 2 terms, you can do factoring. Most of them, we would do factoring. Or we can factor by grouping. So all of these are on one side. When I do factoring, I put everything on one side. So I look at what is the common factor of this term and this term. So the number has no common factor, but x would be x cubed. So you factor x cubed out, and you would say 5x squared, because x squared times x cubed is equal to x5, right? And then minus, if I factor the x cubed out, then it's 7. After you factor it, you can do principle of square root, split into 2. X cubed equal to 0. What is x cubed equal to 0? I do cube root, so x is still equal to 0, right? 5x squared minus 7 equal to 0. Oh, this is a square thing. I have only one square term, so I would do square root. 5x squared equal to 7. Can I do square root yet? No, I need to have everything being square first. So 7 over 5. Clean up everything outside of the square. Divide by 5, divide by 5. And now I'm going to do square root, right? Square root square equal to, but on this side, remember to do plus and minus, 7 over 5. So x would equal to plus and minus square root of 7 over 5. If you want to rationalize it, you multiply square root 5 top and bottom. That will be plus and minus square root of 35 over 5. Okay, so that's the answer. 2 answer. Let's look at the next one for polynomial. This has 2 terms also, so we would do factoring again. Move everything to one side. X to the 4 minus 10x squared equal to 0. So what is the common factor? I can factor the 2 out. I can factor x out, right? That's common to both of them. After I factor the x squared out, this has 4x squared. And this one, if I factor 10 by 2, is 5. But x squared is gone, so I have that. Again, I split into 2, right? Because this is a product. Whenever I have a product, I can do 2x squared equal to 0. And then 4x squared minus 5 equal to 0. Very similar to what we have earlier. 2x squared equal to 0 means x squared equal to 0. And x would equal to 0 because when you do square root of 0, it's just 0. 4x squared minus 5 equal to 0 means 4x squared is equal to 5 because you plus 5 on both sides. Divide by 4 first, divide by 4. So x squared is equal to, take square root, right? Take square root. But this side has to do plus and minus 5 over 4. So I would have x is equal to plus and minus square root 5 over square root 4 is 2. Okay. And I do not need to rationalize in this case because the denominator is done. So I have 3 solutions, x equal to 0, x equal to plus and minus square root 5 over 2. Do I have time to do this one? So this is 4 terms and I have x cubed. So for an x cubed equation, there is no quadratic formula or anything. You have to do grouping. If it has 4 terms, you do grouping. So you group the first 2, x cubed plus x squared. What's the common factor? It's x squared, right? And then so you factor the x out, and this one is not nothing. It's 1 after you factor it out. For negative 4x minus 4, the common factor is 4, right? So it's negative 4. So it's x plus 1 also. And then you will say, well, x plus 1, I can combine them. I can factor it out. X squared minus 4, x plus 1 equal to 0. Now this is a factor, so I can split into 2. X squared minus 4 equal to 0. X squared is equal to 4. X is equal to plus and minus 2 because I do square root, plus and minus. This would be x plus 1 equal to 0. So you see how good it is for factoring. X equal to negative 1. So again, I have 3 answers. Whenever you see an x to the cube and if it has 4 terms, grouping would work. And for other polynomial, if it has 2 terms, a lot of time factoring would work. Okay, so that's how you solve a polynomial equation and also solve equation that has rational exponent.